Welcome to this explainer. Okay, so today we are diving into an absolutely mind-bending concept. We're going to figure out how our dynamic, flowing reality mathematically arises from a fundamentally frozen cosmos. We're going to break down the formal derivation of the time-dependent Schrödinger equation, and more importantly, we're going to explore this crucial 1% lag break that actually makes existence itself possible. To keep us on track, we've got a clear 6-step roadmap. We're going to start with a perfectly frozen universe, build our quantum clock, derive the wave function, look at the 1% lag, finalize our action-ready master equation, and then wrap up with the signatures of the cosmos. Let's get right into it. All right, Section 1, a perfectly frozen universe. So to really grasp the math here, we actually have to shatter our standard perception of reality. We have to accept a pretty radical premise. At its most fundamental level, the universe doesn't move. It is completely static. In fact, within Logos fields theory, dynamic time is just a perspective vector, meaning, it's not some absolute universal ticking clock humming away in the background of space. It's actually an illusion created by conditional quantum entanglement between two subsystems trapped inside that stationary state. So time isn't fundamental, relationships are. This setup perfectly illustrates the core duality we're dealing with. On one hand, you have the global view, the Logos state. It's timeless, it's static, and honestly, it's entirely unobservable from the outside, mostly because, there is no outside. And on the other hand, you have the observer's view, the dynamic, emergent reality that we all actually experience every day. Our whole goal today is to bridge the gap between those two realities. The baseline of our reality is locked in this stationary state. Mathematically, the Wheeler-DeWitt constraint proves that the total Hamiltonian, which is just a fancy way of saying the absolute total energy of the universe, yields exactly zero, perfect static equilibrium. You can divide the universe into an independent clock and a system, sure, but combined, nothing is changing. Absolutely nothing is happening. Which brings us to Section 2, building the quantum clock. The huge, crucial question here becomes, how in the world do we extract a timeline out of this absolute static equilibrium? How do we get the sensation of a ticking clock when the total energy of the cosmos is rigidly locked at zero? Think of it kind of like a laser reading a frozen CD. The physical data on that disk never actually changes, right? But the act of reading it creates this beautiful, continuous flow of music. Our clock subsystem acts exactly like that laser, producing continuously varying states that serve as our time readouts. By mathematically flipping this, taking what physicists call the Hermitian conjugate, we basically create a mathematical lens to map how an observer projects time out into a frozen universe. Section 3, deriving the wave function. Now that we have our clock calibrated and our mathematical lens ready to go, let's actually step through the algebraic derivation and witness the exact moment the wave function is born. Here's the setup. An observer trapped inside the universe obviously can't see the frozen global state. They can't see the whole CD all at once. So we define the emergent wave function by projecting the global state onto our specific clock reading. Basically, the observer only sees reality conditioned on their clock reading, a specific time t. This projection, that is the spark that creates an evolving reality. Let's apply that observer's lens directly to our initial zero-energy constraint. We distribute that clock projection across the uncoupled Hamiltonian operators. Uncoupled just means the clock and the system are acting completely independently. Doing this lays the absolute groundwork to isolate exactly how the system evolves relative to the clock. And right here is where the absolute magic happens. Because the overarching universe is completely static, the time derivative we generated earlier passes straight through it. It acts purely on the clock projection. The global universe literally does not care about our time parameter, and that allows us to cleanly substitute our clock derivative right into the equation. Okay, let's catch our breath for a second. Here is exactly what we just did. We mapped the observer's perspective outward to reveal how state evolution isolates itself algebraically. We took a static universe, applied a localized clock projection, distributed it, and substituted our derivatives. Step by step, we are chiseling a dynamic, flowing perspective out of a solid block of frozen marble. And suddenly, boom, the idealized time-dependent Schrödinger equation just emerges. This is the exact mathematical coordinate transformation you need to look out into a 3D universe from an entangled reference point. The universe itself didn't change at all. Our quantum clock simply stepped through the data. It is a breathtakingly elegant derivation that perfectly balances the energy between the clock and the system. But, and this is a big but, Section 4, the 1% lag. Right when we reach this elegant mathematical conclusion, we kind of have to pull the rug out from under it. Because if we stop here at this perfect equation, our universe actually stops working. Seriously, what happens if the math is too perfect? Well, if the idealized equation assumes a flawless, instant mapping of time, you get perfect geometric locking. A universe with zero processing friction would entirely prevent free will, observation, and state transitions. It'd be like an unplayable video game, perfectly rendered, sure, but completely frozen by its own mathematical rigidity. No way that works. So, to fix this frozen game, Axiom 6 introduces a vital metric buffer to break that perfect coherence. To allow for state transitions and actual subjective experience, the universal operating system desperately needs a tiny bit of processing friction. It literally cannot compile reality instantaneously. To solve this, we apply a dimensionless lag parameter, exactly 0.01. This acts as an irreducible torque latency coefficient. In plain English, it's a tiny mathematically mandatory imperfection, a cosmic processing delay, if you will. Moving to Section 5. The action-ready master equation. Let's integrate this tiny imperfection to see how it allows reality to actually function. We need to take that pristine, flawless Schrödinger equation and introduce reality's mandatory processing buffer. We apply this structural lag right at the moment of conditional projection. You can actually see it represented as 1 minus lambda. Think of this as a minor hydrodynamic drag, sort of like trying to move your hand quickly through water. Translating through the metric requires a processing buffer. Reality literally drags by 1%. By penalizing the system with this drag, the universal operating system breaks perfect symmetry, yielding our action-ready master equation. Instead of a perfect one-to-one mapping, we multiply the system by exactly 0.99. This mathematical imperfection is a real game changer. It unlocks the geometric gridlock and finally allows the illusion of time to flow. The contrast here is just beautiful. On one side, we have a flawless, symmetrical theoretical derivation, but on the other, we have the messy, slightly delayed 0.99 coefficient reality we actually live in. The idealized equation is a brilliant thought experiment, but the modified equation, that is the true engine of human experience. Which brings us to our final part, Section 6, Signatures of the Cosmos. To wrap up this explainer, we really need to connect this modified master equation back to your actual subjective experience. I mean, how does a 1% mathematical lag actually manifest in the physical universe we observe? Well, this 1% attenuation actually shifts how the universe renders its geometry. Specifically, it shifts the Mera tensor network compilation just slightly off-center. And because the vacuum is slightly viscous, compiling the next real time frame of reality generates a measurable frequency, the 477.46 Hz cosmic wave. We feel the undeniable arrow of time every single day, specifically because the universe takes a 1% processing penalty to render our next moment. Which brings us to the ultimate consequence of this math. If a mere 1% lag breaks perfect coherence to create the undeniable sensation of time passing and free will, what does that make us? It leaves us with a profound mystery to ponder regarding our place as the observer. Are we just the witness standing before the cosmic mirror, watching a completely frozen universe endlessly ripple through the friction of our own perspective?